Any physical quantity, such as length, mass, or time, is measured and denoted in terms of their standards, called a unit of measurement. A unit is an internationally accepted basic reference standard against which the measurements of any physical quantity are compared. In physics, we deal with many physical quantities and their units. However, very few basic units are required to express these physical quantities. Most physical quantities are expressed in terms of some base quantities. These base quantities are referred to as fundamental quantities. For example, distance, which is a measure of length, is a fundamental quantity. It's the same with time. The other quantities, which are expressed in terms of their fundamental quantities, are called derived quantities. For example, area or volume, which is expressed in terms of multiples of length, is a derived quantity. Similarly, speed is a derived quantity as its measurement depends on distance and time. The units of fundamental or base quantities are called base units or fundamental units. The units of derived quantities are expressed as a combination of base units. Such units are called derived units. Base units and derived units together make up a system of units. A system of units is a generally accepted set of units of measurement. Until recently, three major systems of units were in use in different countries based on the units of three fundamental quantities, namely length, mass, and time. Among these were the CGS system, which stands for centimeter, gram, second, and FPS, which stands for foot, pound, second, respectively. These units are adopted by Britain, and hence the system is referred to as a British system. The third system of units is the MKS system, which stands for meter, kilogram, and second. However, in 1971, the General Conference on Weights and Measures recommended a standard set of units of measurement with their symbols and abbreviations. This system is known as Système International des Units, French for International System of Units, abbreviated as SI. Currently, SI units are followed globally for all scientific, academic, commercial, technical and industrial purposes. In SI, there are 7 base units for the 7 physical quantities taken as fundamental quantities. Following are the quantities and their corresponding units. Length is measured in meters, denoted by the small letter m. Meter is the length of the path travelled by light in a vacuum during a time interval of approximately 300 millionth of a second. Mass is measured in kilograms, denoted by the small letters kg. Kilogram is equal to the mass of the international prototype of the kilogram, a platinum iridium alloy cylinder kept at International Bureau of Weights and Measures at Sèvres, near Paris in France. Time is measured in seconds. denoted by the small letter s. A second is the duration of approximately 9 billion periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Electric current is measured in ampere, denoted by the capital letter A. An ampere is that constant current which, if maintained in two straight parallel conductors of infinite length, of negligible circular cross-section, and placed 1 meter apart in a vacuum, would produce between these conductors a force equal to 2 multiplied by 10 raised to the power -7 Newton per meter length of the conductor. Thermodynamic temperature is measured in Kelvin, denoted by the capital letter K. A Kelvin is a fraction 1/273.16 of the thermodynamic temperature of the triple point of water. Luminous intensity is measured in candela, denoted by the small letters CD. A candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 power 12 Hz, and that has a radiant intensity in that direction of 1/683 watt per steradian. An amount of substance which contains as many basic entities, such as atoms or molecules, in a system as equivalent to the number of atoms in a carbon-12 isotope is measured in mole, denoted by the small letters MOL. Apart from these base units, SI has defined two more units for two supplementary quantities, namely plane angle and solid angle. Plane angle d theta is the ratio of length of an arc of a circle to the radius of the circle, and is measured in radian, denoted by the small letters RAD. It is defined as the angle subtended at the center of a circle by an arc of length equal to the radius of the circle. Solid angle is defined as the ratio of the intercepted area dA of the spherical surface, described about the apex O as the center, to the square of its radius r, and is measured in steradian, with the symbol SR. If the magnitude of the intercepted area is equal to the square of the radius, then the solid angle is equal to 1 steradian. SI also retained some units from earlier systems for general use. They are minute, hour, day, year, degree, liter, ton, carat, bar, curie, roentgen, quintil, barn, hour, hectare, and standard atmospheric pressure. For all derived quantities, their units are derived from these base SI units. As SI units use the decimal system, it is easy to convert or derive units from base units in this system. You can easily measure length of various entities using appropriate instruments such as a tailor's tape for length of a cloth, a land tape for length of a building, a survey chain for length of roads, etc.